Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lessons 6.6 and 6.7 guided notes on solving one-step inequalities. In the first half of our unit, we focused on solving one- and two-step equations. Now we're going to focus on solving one- and two-step inequalities. We're going to see a lot of the steps being the same, although there will be some slight differences. In addition, as we talked about before the Thanksgiving break, we're also going to show you how to graph your solution on the number line. So let's start by comparing solving equations to solving inequalities. On the left, I have start with number 1. X minus 8 equals negative 12. Let's think about how we would solve that. The inverse of subtracting by 8 is to add 8, so we would add 8 to both sides. So minus 8 plus 8 cancels out, leaving you with x. You would do negative 12 plus 8 in your calculator to get x equals negative 4. Now let's look on the right-hand side at the inequality that looks the same as this equation, number 1. X minus 8 is greater than negative 12. We're going to solve this the same way because the inverse of subtracting by 8 is still to add by 8. So we're going to add 8 to both sides. We're going to be left with x not equal to negative 4, but x is greater than negative 4. Just bring your inequality symbol straight down. But notice how we're going to solve our inequality the same as we do an equation using those inverse operations. Let's look at number 2. X plus 6 equals negative 21, our equation first. The inverse of adding by 6 is to subtract by 6. So in our calculators, we do negative 21 minus 6, which is negative 27. Let's do the same thing for our inequality over here on the right-hand side. Again, the inverse of adding by 6 is to subtract by 6. Negative 21 minus 6 gets us negative 27. So our final solution is x is greater than or equal to negative 27. What's the main point here? We want to solve our inequalities the exact same way we solve our equations using those same inverse operations. All right, let's try some practice. In the exercises, it says to solve each of the following inequalities, showing your work. Then graph the solution set on a number line that's provided. Remember, we want a minimum of 3 numbers on the number line. So number 1, I have g minus 5 is less than negative 8. The inverse of subtracting by 5 is to add 5. So let's add 5 to both sides. Negative 8 plus 5 is negative 3. So our solution is g is less than negative 3. Now you want a minimum of 3 numbers on your number line. So you're going to see that I included negative 3 in the middle. It doesn't have to be in the middle, but that's usually where I put it. Negative 4 is smaller, so it goes to the left. Negative 2 is bigger, so it goes to the right. As a reminder for how we graph our inequalities, we did this before Thanksgiving. Because it's the less than and not less than or equal to, it's going to be an open circle at negative 3. We're going to shade to the left because it's the less than symbol. Keep in mind, we can also realize that since it's the less than symbol, if we make it into an arrow, it happens to be an arrow that points to the left, and that's the direction we shade. All right, let's take a look at number 2. It's a lot of examples, but I do want you to write these down so when we come back together for our live session tomorrow, we'll be able to practice this together, and hopefully you'll have a pretty good base knowledge of it already. So negative 9 is greater than or equal to t plus 8. The inverse of adding by 8 is to subtract 8. So let's subtract 8 from both sides. Negative 9 minus 8 is negative 17. Now, before Thanksgiving break, I also suggested that if you're going to graph your solution, you rewrite it with the variable on the left. So move your variable to the left, your number will go to the right, but you also need to flip your inequality symbol as well. So you'll have t is less than or equal to negative 17. That inequality has the same meaning as the one above it, and I would accept either of these as a solution, but it does help us when we go to graph to recognize that t is less than or equal to negative 17. So again, I do suggest you rewrite it with the variable on the left. The majority of students who don't will graph it wrong. So 3 numbers on our number line. I've got negative 18, negative 17, negative 16, smallest to largest, left to right. Close circle this time though, because it's equal to negative 17. We're going to shade to the left again because it's the less than or equal to symbol. So less than is shaded to the left. Remember, we have to have a meaning of these inequality symbols. All right, number 3. Negative 12 plus m is greater than negative 14. The inverse of adding by negative 12 is to add a positive 12. Negative 14 plus 12 is negative 2. So I get m is greater than negative 2. The variable's already on the left. Let's graph it. I've got negative 3, negative 2, negative 1, smallest to largest, left to right. Open circle this time because it's not equal to. This time, though, we shade to the right because it's greater than negative 2. Again, if you want to make your inequality symbol, this is the greater than symbol, into an arrow. That arrow is going to point to the right, and we're going to shade to the right. All right, let's take a look at our next three. We're going to mix in some decimals and fractions here, so hopefully you have your calculators handy. In number 4, I do suggest you rewrite the equation as n plus 15 is greater than or equal to negative 24. The inverse of adding by 15 is to subtract 15. Negative 24 minus 15 is negative 39. So I have n is greater than or equal to negative 39. Now, three numbers on our number line, negative 40, negative 39, negative 38. Close circle this time because it's greater than or equal to. Remember, this line underneath tells us that it's going to be a closed circle. This time, since it's greater than or equal to, we're going to shade to the right. All right, number 5, negative 9.1 is greater than or equal to p plus 8.6. The inverse of adding by 8.6 is to subtract by 8.6. Now make sure when you plug this into your calculators, you do negative 9.1 minus 8.6. It's really important to be precise and practice this. That's going to get us negative 17.7 is greater than or equal to p. But I'm going to flip everything around so the variable's on the left-hand side, and I'm going to get p is less than or equal to negative 17.7. Again, flip everything around. P goes to the left, negative 17.7 to the right, and flip that symbol around as well. Now, when we go to graph this, you're going to notice I have negative 17.7 in the middle. To the left is negative 17.8, to the right is negative 17.6. You can choose to count in whatever way you want. I've also seen students do just two numbers, negative 17 and negative 18, and then put the negative 17.7 a little closer to the negative 18. That can also work, but I like to just count by tenths. We'll see that as well with some fractions here in just a few moments. This one is a closed circle because of the equal to sign or symbol underneath the less than. Since it's less than or equal to, I'm going to shade to the left. Again, less than, left. We have to know the meaning of these symbols. All right, let's take a look at number 6. G plus 1 1/3 is greater than or equal to negative 2 3/4. The inverse of adding 1 1/3 is to subtract 1 1/3. So in our calculators, keep in mind, we're doing negative 2 3/4 minus 1 1/3. Hopefully you have a calculator handy. If you don't have a calculator and you need to borrow one, let me know. Reach out to me. I can put one down outside of the office with your name on it that you may borrow during this time we are all virtual. So negative 2 3/4 minus 1 1/3 is going to get us negative 4 1/12. So G is greater than or equal to negative 4 1/12. Let's see how I graphed this. So I had negative 4 0/12, negative 4 1/12, negative 4 2/12, which is really negative 4 1/6, but I didn't reduce it. And I didn't put 0/12 here, but you could. So that's the easiest way, I think, to graph it. This one is a closed circle because it's equal to, and it's greater than or equal to, so we shade to the right. We really want to practice this open and closed circle and which direction to shade. We'll practice more of this tomorrow and in the coming days as well. All right, last one of these, number 7, before I have some independent practice, and then we're also going to do one-step inequalities by multiplying and dividing. That way we get this out of the way and we can practice it together during our live sessions this week. So negative 2 4/5 is less than x minus 3 1/4. The inverse of subtracting 3 1/4 is to add 3 1/4. So what you're plugging into your calculators is negative 2 4/5 plus 3 1/4. That will get you 9/20 is less than x, and then rewrite it with the variable on the left. I do those as separate steps. Don't try to combine too many steps at once. So flip everything around and you're going to get x is greater than 9/20. Keep in mind the meaning is the same because the mouth of the alligator is facing the x here and here. The pointed part of the arrow is facing the 9/20 both here and here. All right, I've got 8/20, 9/20, and 10/20, which 8/20 and 10/20 do reduce. I've got an open circle at 9/20. Since it's greater than 9/20, I'm going to shade to the right. Again, you don't need to reduce these fractions. I'm okay with you writing it like this. All right, so next I do have 2 independent practice problems for you to try. Find some space on some paper or in your notes, pause the video, try these, and when you're ready, start it again. All right, I hope you've seen both of these questions. So in number 1, the inverse of adding by 19 is to subtract 19. That's going to get us x is less than negative 30. So what our graph is going to look like is open circle at negative 30. Because it's x is less than negative 30, we're going to shade to the left. So open circle, shaded to the left. All right, let's take a look at number 2. We have negative 23 is less than or equal to x minus 15. The inverse of subtracting by 15 is to add 15. Negative 23 plus 15 is negative 8, but I did rewrite it with the variable on the left, so it becomes x is greater than or equal to negative 8. Let's take a look at our graph. So for our graph, we've got negative 9, negative 8, negative 7. I've got a closed circle at negative 8, and I'm going to shade to the right, since numbers that are greater than or equal to negative 8 are to the right. Keep in mind, you can check your solutions for these as well. It's not something we've talked about before, but if you choose a number that's greater than negative 8, like 0, for example, and replace x with 0, 0 minus 15 is negative 15. You get negative 23 is less than or equal to negative 15. Is that true? Yes, it is. And if it's true, then it means that you have the correct solution. The same way here, x is less than negative 30. You could put a number like negative 50 in for x and do negative 50 plus 19. Negative 50 plus 19 is going to get us negative 31, which is less than negative 11. It's a way you can check your solutions even for inequalities. All right, so we also need to talk about how to solve one-step inequalities by multiplying and dividing. There is a little bit of a trick here, so pay close attention. All right, so I've got equations on the left, inequalities on the right. 8x equals 24. The inverse of multiplying by 8 is to divide by 8. That's going to get us x equals 3. 24 divided by 8 is 3. Let's look at our inequality. We're going to use that same inverse operation, divide by 8. We get x is greater than 3. Just bring that symbol straight down. Number 2, x over 6 equals negative 5. The inverse of dividing by 6 is to multiply by 6. Do negative 5 times 6 to get negative 30. So our solution is x is greater than negative 30. We do the same here for number 2. The inverse of dividing by 6 is to multiply by 6. So we get x is greater than or equal to negative 30. Again, solve your inequalities the same as you solve equations using those inverse operations. But wait a minute. Let's look at this example. Negative 5x is less than 25. The inverse of multiplying by negative 5 is to divide by negative 5. That'll get us x is less than negative 5. This means that all numbers less than negative 5 are solutions. So negative 6 should be a solution, but doesn't work. Negative 5 times negative 6 is 30. Is 30 less than 25? It's not. What about negative 10? Negative 5 times negative 10 is 50. Is 50 less than 25? It's not. So numbers that are less than negative 5 don't actually make this true. But if I flip my inequality symbol around, and only my inequality symbol around, I get x is greater than negative 5. Do numbers greater than negative 5 make this true? Numbers like 0 or 1 or 2. If I do negative 5 times 0, I get 0. Is that less than 25? It sure is. What about 1? Negative 5 times 1 is negative 5. Is that less than 25? It is. The main point here, notice these big stars that we've got. They're yellow and bright right here on the screen. If you multiply or divide both sides of an inequality by a negative number, which we did not see over here, we multiplied or divided by positives. If you multiply or divide both sides of an inequality by a negative number, you must switch the inequality symbol so it points the opposite direction. Just the symbol. There will be times we'll rewrite it with the variable on the left, but here we're just switching the symbol. So let's look at number 2. X over negative 7 is greater than or equal to negative 9. The inverse of dividing by negative 7 is to multiply by negative 7. But I multiplied both sides by a negative number. It doesn't matter if the answer is negative. It matters that what we did to both sides was multiplied or divided by a negative, which I did here. I must flip my inequality symbol around. So it becomes x is less than or equal to negative 9 times negative 7 is positive 63. Notice how I flipped my inequality symbol around so it points the opposite direction. It changes the meaning of the inequality, which is important here for our solution to be correct. All right, number 3. Negative 12x is greater than 144. The inverse of multiplying by negative 12 is to divide by negative 12. 144 divided by negative 12 is negative 12. But I divided both sides by negative 12, which means I have to flip the symbol around. So it was greater than, it becomes the less than symbol in order for my solution to be correct. So again, anytime you multiply or divide both sides of an inequality by a negative number, you need to flip the inequality symbol around. That's so important. All right, let's take a look at some. Some will need to flip the inequalities. Others we will not. Number 8, 5g is less than negative 45. The inverse of multiplying by 5 is to divide by 5. I divided by a positive. I do not need to flip the symbol around. So I get g is less than negative 45 divided by 5 is negative 9. Let's graph it. The graph should become pretty routine at this point. I've got negative 10, negative 9, negative 8. Open circle at negative 9. It's less than, so I shade to the left. All right, number 9. Negative 9 is greater than or equal to t over negative 11. The inverse of dividing by a negative 11 is to multiply by negative 11. Negative 9 times negative 11 is 99, but you're going to notice that I flipped the symbol around. I'm going to highlight this in yellow. So the greater than or equal to became less than or equal to because I multiplied by a negative 11. But rewrite it with the variable on the left. So it becomes t is greater than or equal to 99. We should still rewrite it with the variable on the left, but I do these in 2 separate steps because this highlighted part changes the meaning. I flipped only the symbol. From here to here, from this line to this line, the meaning stayed the same. I flipped everything around, which kept the meaning the same. So my final solution is t is greater than or equal to 99. Close circle at 99, I shade to the right. Make sure you have that jotted down. That one's tough. All right, let's take a look at number 10. Negative 4m is greater than negative 16. The inverse of multiplying by negative 4 is to divide by negative 4. I divided by a negative, so I have to flip the symbol around. It becomes m is less than 4. Negative 16 divided by negative 4 is positive 4. Open circle at 4, shade to the left since it's less than 4. All right, let's try a few more. N over 8 is greater than or equal to negative 5. The inverse of dividing by 8 is to multiply by 8. Negative 5 times 8 is negative 40. I do not need to flip the symbol around because I multiplied by 8. Is the answer negative? Yes, but I only care this step that I multiplied by a positive 8. For this one, close circle because it's equal to. Greater than or equal to means I shade to the right. Now I'm going through my graphs pretty quickly here. You may need to take your time working through those, so feel free to pause the video at any time to jot them down. All right, number 12. 3 is less than negative r over 8. I do suggest you rewrite it with the negative, either with the r or the negative 8. I like to put it with the 8. All right, so the inverse of dividing by -8 is to multiply by -8. I multiplied by a negative, so I'm going to flip the symbol around. Notice how from here to here I flip the symbol. 3 times -8 is -24. But I'm also going to rewrite it with the variable on the left. So I flip everything around. Its r is less than -24. Open circle at -24. I'm going to shade to the left because it's less than. Be careful here. These are tricky. You will not see something quite as difficult as this on your test, but I still think it's good practice. All right, we've got a few more. Let's finish up this video. Y over -4.8 is less than -3. The inverse of dividing by -4.8 is to multiply by -4.8. But I multiplied by a negative, so I've got to flip that symbol around. We get y is greater than -3 times -4.8 is 14.4. So I've got 14.3, 14.4, 14.5. Open circle in this case. Because its y is greater than 14.4, I shade to the right. All right, let's take it home with our last 3 problems, and then I have a few for you to try independently. We'll see more of these tomorrow, though, too. 25w is greater than -200. The inverse of multiplying by 25 is to divide by 25. I'm getting ahead of myself. -200 divided by 25 is -8, so I get w is greater than -8. No need to flip that symbol because I divided by +25. This one will have an open circle at -8. Greater than means I shade to the right. All right, number 15, we have -1/2 times b is greater than -6. The inverse of multiplying by -1/2 is to divide by -1/2. Now I did divide by a negative value, so I've got to flip the symbol around. -6 divided by -1/2. Dividing by -1/2, by the way, is the same as multiplying by -2, something we skipped over this year, but I know you've seen that before. Should get us 12. b is less than 12. For this problem, we're going to have an open circle at 12. Since it's less than, we're going to shade to the left. All right, last one of these. 2 1/3 r is less than -3 1/2. The inverse of multiplying by 2 1/3 is to divide by 2 1/3. So do -3 1/2 divided by 2 1/3. No need to flip the symbol around because I divided by a positive. You'll get r is less than -1 1/2. So I've got -1, -1 1/2, -2 from right to left. Open circle because it's not equal to. Since it's less than, we shade to the left. All right, 3 problems for you to try independently. Pause the video, try all 3. I didn't ask you to graph these, just solve them. Okay, I hope you've tried all 3 of these. These are the last 3, and then we're done with the video for today. So 12x is greater than or equal to -60. The inverse of multiplying by 12 is to divide by 12. -60 divided by 12 is -5. You do not need to flip the symbol here because you divided by a positive. Number 2, the inverse of dividing by -3 is to multiply by -3. You do need to flip the symbol here, though, because you multiplied by a negative, so you get x is greater than 63. Number 3, the inverse of multiplying by 7 is to divide by 7. I do not need to flip the symbol because I divided by a positive, so I get -8 is less than or equal to x. I kept the symbol the same direction, but I do suggest you rewrite it with the variable on the left, which is not the same as flipping just the symbol. I'm rewriting the inequality with the variable on the left, so we get x is greater than or equal to -8. All right, there's a lot here. We're going to take a look more at this tomorrow, so be ready for us to see some practice with this. But hopefully you have the main ideas here. You already know how to solve equations. We're really doing the same thing with inequalities, but we do have to graph our solutions. And remember that weird trick of when you multiply or divide both sides of an inequality by a negative, you got to flip the symbol. Thanks for listening.